Welcome back to our system design series. Today we are going to discuss an essential concept in distributed systems, the CAP theorem. The CAP theorem is a fundamental principle that helps us to understand the trade-offs involved when designing a distributed database or distributed system or any distributed services. So, what is a CAP theorem? It is the CAP theorem states that in a distributed system, it is impossible to simultaneously guarantee the three things that we are going to see: consistency, availability, and partition tolerance. In other words, you can only pick two out of the three properties, and understanding understanding these trade-offs is crucial for making informed decision in the system design. So first, let's start with the consistency. Consistency means that every read received, the most recent write or an error. In a simpler terms, all nodes in a distributed system should have the same data at the same time. For instance, if you update a record in a database node, all nodes should reflect that change instantly. Okay, availability. Availability means that every request receives a response, even if it's not the most up to date. In other words, the system should always be able to serve requests, even if that means temporarily providing slightly outdated information. High availability is often crucial for user facing services to ensure they are always responsive. Lastly, partition tolerance. Partition tolerance means that the system continues to operate despite network partitions or communication breakdowns between nodes. In a distributed environment, network issues are inevitable. Partition tolerant system must handle these failures gracefully. So we cannot ignore partition tolerance. So when we try to design a distributed system, basically we try to choose between consistency and availability. Basically, we're trying to choose between a CP system, let's make it thick, a CP system or a AB system, AP system. So, as I said before, the CAP theorem tells that tells in the face of network partition, we have to make choice between consistency and availability. If consistency is chosen and partition tolerance, the system will ensure that all nodes have the same data, but it might sacrifice availability during a network partition. An example of this would be like a system that prioritizes data integrity over time, like a financial application where correctness is critical. Number two, if you choose availability and partition tolerance, the system will always be available to serve requests, even during network partitions, but it may provide inconsistent data. This trade-off is common in social media platforms where availability is higher priority and temporary inconsistencies are acceptable. If you choose consistency and availability, which is CA type systems, the system can provide consistency and high availability, but this combination is only possible if there are no network partitions. And in a real-world distributed system, partitions are inevitable. So a true CA system is not feasible under all circumstances. So it's not a real-world system. So basically, you choose between CP and AP. So let's look at an example to make this more tangible. Imagine you are building a distributed online shopping platform during a major sale. Network connectivity between different data centers becomes unreliable according to the CAP theorem. You can't have all these three properties simultaneously. So if you prioritize consistency, you might temporarily block user requests to ensure everyone sees the correct inventory count, sacrificing availability. If you prioritize availability, you might allow users to continue shopping even if they might not see the latest inventory updates, sacrificing consistency. And of course, because partitions are inevitable, you must ensure partition tolerance so that the system doesn't break entirely. So the choice between consistency and availability depends on your use case. For example, financial systems tend to favor consistency to to prevent incorrect transactions, while social networks tend to favor availability to ensure users can always post and view content, even if the data isn't perfectly up to date. So yeah, that's it for the CAP theorem. And yeah, if you enjoyed this series or sharing this video, make sure to subscribe and hit the notification bell so you'll never miss any videos. And see you guys in future problems.